If we took the fastest spacecraft ever built by humanity and launched it straight toward the TRAPPIST-1 system, how long would it take us to get there? Decades? Centuries? Or maybe the lifespan of an entire civilization? Imagine a journey so long that no human generation would live to see it end. A destination so distant that even light, traveling at 300,000 kilometers per second, would take 40 years to cross the space between us and it. But our spacecraft don't travel anywhere near that. It's a simple question, but the answer reveals something profound: the true size of the universe that surrounds us, and how small we still are in the face of it. Before we go on, if this topic fascinates you, leave a like, subscribe, and turn on notifications. It helps the channel and lets you know about upcoming videos. Before trying to calculate the travel time, we need to understand what exactly this mysterious destination is: the TRAPPIST-1 system. TRAPPIST-1 is a small star located about 40 light-years from Earth in the constellation Aquarius. It was discovered in 2016 by the TRAPPIST telescope, a Belgian project that searched for rocky worlds beyond the solar system. But what really caught attention was what orbited this star: 7 planets, all similar in size to Earth. A discovery like this fired up the imagination of astronomers around the world, not just because of the number of planets, but because some of them seem to lie in the so-called habitable zone, the region where temperatures could allow liquid water on the surface. And speaking of stars, TRAPPIST-1 is quite different from our Sun. While the Sun is a yellow, hot, and active star, TRAPPIST-1 is an ultracool dwarf with only 9% of the Sun's mass. If you placed it side by side with Jupiter, it would look only slightly larger. That means its light is faint but stable, and its planets are incredibly close to it, orbiting at distances so small they would fit well within Mercury's orbit. Imagine a system where all the worlds are packed around a single star like pearls on a tight necklace. Each of these planets has a year that lasts just a few days. TRAPPIST-1b, the closest, completes an orbit in just over a day and a half. The farthest, TRAPPIST-1h, takes only 18 days to go around its star. It's a compact and harmonious mini-solar system. Astronomers say that if you were on one of these planets, you could see the others as enormous moons in the sky, perhaps even making out their continents and oceans, if they exist. But what fascinates most is how similar these worlds are to ours. They are all rocky, and some have densities very close to Earth's. Planets D, E, and F are the most promising, located in the zone where temperatures could allow oceans. One of them, TRAPPIST-1e, is so Earth-like that many scientists consider it the best candidate for habitability outside the solar system. Since its discovery, TRAPPIST-1 has become a true natural laboratory. Telescopes like James Webb have been observing this system closely, searching for signs of atmospheres and possible hints of biological molecules. Webb has already detected the absence of large hydrogen-rich atmospheres on some planets, which is good news as it increases the chance of finding thin atmospheres similar to Earth's. Each new observation brings a mix of hope and humility, because the more we study TRAPPIST-1, the more it seems like a distant mirror of our own system. 7 worlds, a star at the center, and the eternal question: are we alone? But dreaming about TRAPPIST-1 is easy. The problem is getting there. 40 light-years may sound like a reasonable distance. After all, only 40. But what does that really mean? A single light-year equals 9.46 trillion kilometers. In other words, TRAPPIST-1 is about 380 trillion kilometers away from us. It's a distance so vast, it completely escapes our intuition. To grasp this scale, let's look at the fastest spacecraft we've ever launched. Voyager 1, launched in 1977, is the most distant human-made object from Earth. It travels at about 61,000 kilometers per hour and has been moving away from the Sun for nearly half a century. Even so, it still hasn't fully left the influence of our solar system. Today, it's just over 24 billion kilometers away. That is, less than 0.0025% of the way to TRAPPIST-1. Another candidate is New Horizons, which flew past Pluto in 2015, traveling at about 58,000 kilometers per hour. At that same speed, it would take nearly 800,000 years to cover the 40 light-years to TRAPPIST-1. And even the fastest of all, the Parker Solar Probe, which reaches peaks of 700,000 kilometers per hour when it nears the Sun, would need more than 9,000 years to traverse a single light year. Multiply that by 40 and you get an absurd number, 360,000 years of travel. In other words, with current technology, TRAPPIST-1 is completely beyond our physical reach. But that doesn't mean it will always be this way. Over the decades, scientists have envisioned far more efficient propulsion methods. Ion engines, for example, are already used on modern probes and can reach speeds much higher than chemical engines, but even they would take thousands of years to get there. Other bolder ideas involve solar sails, huge reflective surfaces that would use sunlight or lasers to accelerate small probes. This is the basis of the Starshot project, envisioned by Stephen Hawking and Yuri Milner. The proposal is to send mini spacecraft weighing just a few grams, pushed by powerful Earth-based lasers, capable of reaching up to 20% of the speed of light. If this technology becomes real, we could reach TRAPPIST-1 in about 200 years, unthinkable today, but perfectly plausible for future generations. Even so, it would be a long-duration, likely intergenerational mission, where only the descendants of the first crew would see the final destination. And if we dream even bigger, some theoretical concepts propose propulsion with antimatter, nuclear fusion engines, or even warp drives like Alcubierre's, which would deform spacetime itself to shorten the route. These ideas are still far from practical reality, but they show that, at least in theory, interstellar travel isn't impossible, just unlikely with current technology. Meanwhile, our telescopes keep doing what they can, observing. James Webb, Spitzer, and Hubble have already revealed incredible details about this system, such as the precise sizes of the planets and the approximate composition of their surfaces. But we still lack the most important piece, proof of life. And that's the irony of space exploration. We can study the chemistry of a planet 380 trillion kilometers away, but we can't send a single spacecraft there. The universe shows us the path, but it hasn't yet given us the feet to walk it. Now that we understand what TRAPPIST-1 is, its worlds, and the colossal distance that separates us from it, let's return to the question we asked at the beginning. How long would it take us to get there? With Voyager 1, it would be about 700,000 years. With New Horizons, 800,000 years. With the Parker Solar Probe, 360,000 years. And even with the most advanced project we can imagine today, Starshot, it would still take around 200 years. Assuming everything worked perfectly. In other words, even our best spacecraft are like cosmic turtles trying to cross an infinite ocean. TRAPPIST-1, for now, is a distant dream, a beacon that lights our curiosity, but that we still cannot reach. But maybe that's exactly where the beauty lies. Because science isn't about what we've already achieved, but about what we're still trying to understand. Perhaps, in some distant future, when humanity masters fusion or learns to manipulate space-time, someone will finally look out a spacecraft window and see 7 worlds dancing around a small reddish star. And when that day comes, they might remember us, the first ones who looked to the sky and asked, "How long to TRAPPIST-1?" If this journey made you think about the size of the universe and humanity's incredible drive to go further, leave a like and subscribe to the channel. That way, you'll travel with us in every new episode about the cosmos. And who knows, maybe one day we'll be telling the story of how we finally got there. Thanks for watching, and see you in the next video.